This right here is a piano, but it's not just any basic 3D printed piano. This piano can actually make music. More specifically, it can play the Harry Potter theme song. So welcome back to Knowledge on Ears, and in today's video we're going to divide this into two parts. We're going to take a look at how we made this 3D printed piano and how we did the 3D printing, and then we're going to take a look at the theory, at how the music box inside of this works to make the sound. Let's get going. So this model right here is the online model that I used to 3D print my piano. And I found this one on Bamboo Studio. You can also find it online. And it works pretty well. It's super realistic, and I also had a music box to go along with it. You can see that there are 6 plates over here I had to print out individually, and then I super glued them together. And in total, it took like around 5.8 hours for the whole printing process, so it works great. Now let's get into a quick time lapse of how some of the printing went. This is a time lapse that I captured during printing. Now let's get into the theory. This neat little structure right here is responsible for producing the music, the sound, inside of the piano, and we call this a music box. So there's many different types of music boxes out there. This one is called the crank handle music box because obviously it has a handle that we spin to manually produce the music. But there's also other ones like wind up music boxes where we also spin it, but when we wind it up to play the whole song. But how can such small music boxes produce large songs? Well, let's dive into it. So right here, we know that this is the crank handle. And if we look closely, the crank handle has a bunch of these indentations, these grooves. And beside it, there's a gear that connects straight into those grooves. So when we spin the crank handle, the gear also spins. And the gear is connected to the cylinder part. And we call this part the drum of the music box. And on the drum, there's a bunch of these spiky, extruding pieces. And those pieces are called the pins of the drum. So basically, when we spin the crank handle, the gears spin, and then that makes the drum spin. But how is sound even produced? So right here, there's this interesting looking piece, and this is called the comb of the music box. And the comb has a bunch of these individual teeth, these individual rectangular parts. But once again, how are different notes even produced? So if we play the music box, so we can see that there are different notes. There are different sounds being produced. They're not all the same sound. Well, that's because each of these different teeth represent a different note. How? They all look the same. No, they actually aren't the same because each of these teeth are different lengths. If you look closely, they're all different lengths. These are the shortest, and these are over here are the longest. Why does that even matter? Well, obviously, the difference in length actually creates a different sound. So shorter teeth have a higher frequency because what they do is that they actually vibrate so much faster. So when the pins hit the shorter teeth, then that makes the shorter teeth vibrate so much faster, which creates shorter wavelength sounds, shorter wavelengths, and then that makes the frequency so much higher, the frequency of the sound that's produced. But for the longer teeth, when a pin actually strikes the longer teeth, what happens is that there's longer wavelength sound being produced, which makes it a lower frequency. And so that's what produces these different pitches, these different sounds to us in our ears. If you see, the pins actually are striking these teeth. And obviously we already went over the fact that different sounds are being produced. So that's why these pins are arranged in a specific order to make sure that the different sounds are being produced, and then also the timing is right of the song. So the pins are arranged in a specific order, and then these teeth are arranged with different lengths to produce different sounds. So that's how it works. But you might have noticed that when I play this in the air, you can barely hear it when I play it out here, but when I put it down, so So you can actually hear it very well when it's on a surface, when it's sitting on something. Well, that's because of something known as resonance, and it's pretty complicated, but what happens is when you play it in the air, the vibrations that are produced when the pins hit the teeth, it has nowhere to go. The vibrations have nowhere to go but the air, and the air is not that great at transmitting vibrations. And when you put it on the ground, however, when you put it on a solid surface, the surface picks up these sounds that are produced. It picks it up, it hits them, and it amplifies the sound. It resonates. It's like a resonating type of thing. And it resonates it and makes it sound so much louder. So that's why it helps. That's why we have a music box. That's why we have a piano. We have to put it on something to actually make it actually produce the sound and amplify it. So that's how it works. I hope this made sense. Thank you so much for listening. I hope you enjoyed this project. Bye!